Most people think tracking is a cookies problem. Clear your cookies, block third-party cookies, run an incognito window, and you're supposedly starting fresh. That mental model stopped being true a while ago. Two storage mechanisms built into every modern browser, list of trace and IndexedDB, can hold onto an identifier long after the cookies are gone, and neither one was ever designed with tracking in mind. They were built to make websites work better offline, and tracking is just a use somebody found for them later, quietly, without ever asking permission the way a cookie banner at least pretends to. I run real proxy and cloud phone farms, and I test anti-detect browsers hands-on for multi-account work, not off a spec sheet. So when I say the isolation these tools sell is really just isolation of storage buckets, that's from watching the actual data on disk, opening profile folders and comparing what's inside them byte by byte, not from marketing copy on a pricing page. I've also watched platforms catch profiles that had perfectly clean storage, which is the part most explainers skip. Loastertrend is a simple key value store built into every browser. Any website can write string data into it and read that same data back on your next visit, and there's no expiration date unless the site or you clear it yourself. It's kept around 5 to 10 megabytes per origin, depending on the browser, which sounds small until you remember an identifier only needs to be a few dozen characters long. A site can fit thousands of unique IDs in the space it takes to store one blurry photo, and most sites only ever write a handful of small values in there anyway. IndexedDB is a different thing entirely, a real transactional database sitting inside the browser, also scoped per origin, and it can hold a lot more structured data, including blobs, with indexes and queries the way an actual database works. It was built for offline-capable apps, things like email clients and note-taking tools that need to cache real data locally so the app still works on a bad connection or on a plane with no signal. Nobody designing IndexedDB set out to build a tracking pixel replacement, but it turned out to be a very good one, mostly by accident of what it was capable of storing quietly. Both of them share one property that makes them useful for tracking anyway. They persist independently of cookies. They don't get sent automatically with every HTTP request the way a cookie does. And until fairly recently, browsers did almost nothing to isolate or limit them between sites. That combination, quiet, persistent, roomy, and mostly unpoliced, is exactly what a tracking script wants. And it's why the shift away from cookies didn't actually reduce tracking. It just moved where the ID lives. Third-party cookie blocking has been rolling out for years now. Safari's intelligent tracking prevention, Firefox's total cookie protection, and Chrome phasing out third-party cookies in stages after years of delay and plenty of pushback from the ad industry. Once cookies stopped reliably following someone across sites, tracking scripts needed somewhere else to stash an identifier, and storage was sitting right there waiting, mostly untouched by the same restrictions that were closing in on cookies specifically. A script can write a unique ID into lastportrait or IndexedDB on the first visit and read that same ID back on every later visit to that origin, with no server round trip needed to do it. Combine that with cache entries, service worker state, and e-tags, and you get what people in the tracking world call an ever-cookie pattern, the same ID written to 5 or 6 places at once, so clearing any one of them doesn't kill it. The script just checks each location on the next visit and respawns the ID from whichever spot survived the cleanup, so a user who thinks they wiped everything is usually only wiping the one location they knew to look at. The more common setup I actually see now isn't storing the whole tracking ID in IndexedDB directly. It's using IndexedDB to remember the result of a fingerprint. A site runs its usual collection, canvas rendering, WebGL parameters, audio stack fingerprinting, installed fonts, screen resolution, hardware concurrency, then hashes all of it down into a single compact value that's supposed to be unique to your machine and stable across visits. None of that collection needs your permission or even a page reload to run. It happens in the background the moment the page loads. On the first visit, the site writes that hash into IndexedDB and moves on without you noticing anything happened. On the next visit, it recomputes the fingerprint fresh, checks whether a matching hash already sits in storage, and if it does, it treats you as a returning visitor. That match happens even if you wiped every cookie in the browser between the two visits, because the thing being compared was never a cookie in the first place. It was a database entry sitting somewhere most people never think to look. That's why clearing cookies alone rarely resets tracking on a site that takes it seriously. The fingerprint itself was never sitting in a cookie to begin with. The cookie was just the easy, well-known place to store a pointer to it. And once trackers realized they could keep that pointer in IndexedDB instead, cookie clearing stopped functioning as a reset button for anyone paying attention, even though most users still believe it works exactly that way. Browser vendors know all of this, and the fix that shipped gradually over the last few years is storage partitioning, sometimes called double keying. Instead of one shared IndexedDB or low storage bucket per origins, browsers now key storage to the combination of the top-level site you're on and the embedded origin making the request. A tracking script loaded on 10 different sites through an add slot used to be able to read the exact same IndexedDB entry on all 10 of them, stitching your visits together into one profile without you ever logging in anywhere. With partitioning turned on, that same script gets a separate empty storage bucket on every site it loads on. So the ID it wrote while you were on site A is completely invisible to it on site B. Safari led on this rollout, Firefox followed with total cookie protection, doing something similar, and Chrome has partitioned storage APIs behind an ongoing staged rollout of its own, years behind the other two but moving in the same direction. This closes the cross-site correlation angle for third-party trackers loaded through iframes or ad scripts, which was a huge chunk of the tracking industry's business model for a long time. But it does nothing at all for first-party tracking, where the site you're directly typing the address for reads its own IndexedDB to recognize you, visit that same site twice in the same browser profile, log into the same shopping cart or the same social feed, and its own storage bucket and its own fingerprint hash are still sitting there waiting to match up, partitioning or not. Because partitioning was never meant to stop a site from remembering its own visitors. A marketplace, a social platform, a booking site, whatever it is you're logging into more than once is squarely in this first-party category, and that's exactly the category multi-account work lives in. This is the part that actually matters if you're running more than one account on the same platform. Tools like multilogin, GoLogin, Camelio, AdsPower, and Dolphin Anti each give you separate browser profiles, and each profile gets its own separate storage, its own Lester preset, its own IndexedDB, its own cookie jar, its own cache, kept apart on disk from every other profile you run. The same way two different people's laptops would never share a browsing history. I've opened the data directories myself and compared them side by side, profile folder by profile folder. That's a real thing happening on disk, not a marketing claim printed on a features page. Profile A's IndexedDB fingerprint hash simply isn't visible to Profile B, because under the hood, they're different browser instances pointed at entirely different underlying folders. The same way two separate installs of the same app on the same computer wouldn't share a save file just because they're running the identical program. That solves one specific narrow problem, which is the one this whole breakdown has been building toward. A platform can't use IndexedDB to link your second account back to your first purely through shared storage, as long as the profiles stay genuinely separate and you're not logging into both of them from the same machine session in some other way that leaks the connection anyway, like using the same email recovery flow or the same payment method on both. Storage isolation says nothing about the other fingerprinting surfaces a platform can check completely independently of whatever's sitting in IndexedDB. Canvas and WebGL rendering fingerprints, installed font lists, screen resolution, CPU and GPU details, and hardware concurrency all live at the rendering layer, not in a storage bucket, so wiping or isolating storage never touches them at all. Timon versus IP location mismatches, TLS handshake ordering, how HTTP2 negotiates the connection, and behavioral signals like typing cadence or mouse movement sit at a different layer again, the network and behavior layer, and none of that has anything to do with what's written to disk either. A platform doesn't need to touch your IndexedDB at all to notice that 5 different profiles all report the same GPU renderer string, the same install font set, and connect from IP ranges that belong to the same hosting provider. And that pattern alone is often enough on its own to flag an account for review. No anti-detect browser makes a profile undetectable, and none of the tools I just named should be treated as unbannable just because their storage isolation happens to be doing its job correctly. Storage isolation removes exactly one correlation vector out of many. Platforms that actually care about catching multi-accounting are checking a lot more than that single vector. And detection teams update what they look for on their own schedule, not on ours, which is part of why nothing in this space stays static for long, and why a setup that worked cleanly 6 months ago isn't a guarantee today. The browser vendors are still tightening partitioning rules as we speak, closing edge cases where storage could leak between contexts in ways nobody originally intended. That trend is only going to continue, which means the gap between what storage isolation covers and what a platform actually checks keeps shifting under everyone's feet, including the platforms themselves, who are constantly adjusting their own detection to account for what the browsers just changed. If you're running real proxies and separate profiles for legitimate multi-account work, treat storage isolation as necessary and absolutely not sufficient on its own. Pair it with proxies that actually match each profile's claimed location instead of an obviously mismatched exit node. Don't share font installs or GPU drivers across profiles in a way that makes them look identical at the rendering layer, and don't assume that because IndexedDB is clean, everything else about the profile is too. Because a detection system checking one layer while you only hardened another is how clean-looking accounts still end up flagged. It tests these browsers on real multi-account setups, so the written reviews and the picks I actually trust are all at antidetectbrowser.org. Full written reviews and tested picks at antidetectbrowser.org. Go take a look and subscribe if you want the next breakdown when it's out.